Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Researchers may have found a promising alternative to conventional lithium-ion batteries made from a common material, rubber. We've learned something fundamental about the system for making new materials, said Northwestern's Chad Mirkin, the George B. Rathmann Professor of Chemistry in the Weinberg College of Arts and Sciences and a co-corresponding author of the paper in Nature Materials. This strategy for breaking symmetry rewrites the rules for material design and synthesis. Nanoparticles have the potential to enable new materials with properties that can be carefully designed, but one of the big challenges is making these materials self-assemble. Crystals that can transform light may be engineered for everything from light sensors and lasers to communications and computing. Using large and small nanoparticles, where the smaller ones move around like electrons in a crystal of metal atoms, is a whole new approach to building complex colloidal crystal structures, said Sharon Glotzer, the Anthony C. Lembke Department Chair of Chemical Engineering at and a co-chorus. By tuning parameters like the length of the DNA and how densely the nanoparticles are coated, the metal nanoparticles can be programmed to arrange themselves in specified ways. As a result, they are called programmable atom equivalents. However, the atoms in this crystal, spheres with an even coating of DNA, are the same in all directions, so they tend to build symmetric structures. To build less symmetric structures, they needed something to break the symmetry. Building on Chad's prior discovery of electron equivalence, with Northwestern's Monica Olvera de la Cruz, we explored more complex structures where control over the number of neighbors around each particle produced further symmetry breaking, Glotzer said. That data revealed three complex, low-symmetry structures. One, whose twisted tunnels are known as a triple double-gyroid structure, has no known natural equivalent. We're in the midst of an unprecedented era for materials discovery, Mirkin said. This is another step forward in bringing new, unexplored materials out of the sketchbook and into applications that can harness their incredible properties. The study was supported primarily by the Center for Bio-Inspired Energy Science, an Energy Frontier Research Center funded by the U.S. DEPA. Make a difference. Sponsored Opportunity Story Source. Materials provided by University of Michigan. Note: content may be edited for style and length. The emergence of valency in colloidal crystals through electron equivalence. Nature Materials, 2022. doi. 10. 1038 per second 41563, 021, 01170. 5. Cite this page. University of Michigan. University of Michigan. 2022, January 13. Nanostructures get complex with electron equivalence. Nanoparticles of two different sizes break away from symmetrical designs. https://ift. tt. 3A0 MGSU. Access January 14, 2022. Chan School of Public Health researchers. Their findings will be published online in Science on January 13, 2022. The hypothesis that EBV causes MS has been investigated by our group and others for several years, but this is the first study providing compelling evidence of causality, said Alberto Ascherio, professor of epidemiology and nutrition at Harvard Chan School and senior author of the study. This is a big step because it suggests that most MS cases could be prevented by stopping EBV infection, and that targeting EBV could lead to the discovery of a cure for MS. MS is a chronic inflammatory disease of the central nervous system that attacks the myelin sheaths protecting neurons in the. Establishing a causal relationship between the virus and the disease has been difficult because EBV infects approximately 95% of adults. MS is a relatively rare disease, and the onset of MS symptoms begins about 10 years after EBV infection. To determine the connection between EBV and MS, The researchers conducted a study among more than 10 million young adults on active duty in the U.S. military and identified 955 who were diagnosed with MS during their period of service. The team analyzed serum samples taken biennially by the military and determined the soldiers' EBV status at time of first sample and the relationship between EBV infection and MS onset during the period of active duty. In this cohort, the risk of MS increased 32-fold after infection with EBV but was unchanged after infection with other viruses. Serum levels of neurofilament light chain, a biomarker of the nerve degeneration typical in MS, increased only after EBV infection. The findings cannot be explained by any known risk factor for MS and suggest EBV as the leading cause of MS. Asherio says that the delay between EBV infection and the onset of MS may be partially due to the disease's symptoms being undetected during the earliest stages and partially due to the evolvin. Currently there is no way to effectively prevent or treat EBV infection. But an EBV vaccine or targeting the virus with EBV-specific antiviral drugs could ultimately prevent or cure MS, said Asherio. Other Harvard Chan School researchers who contributed to this study include Chetel Bjornovic, Mariana Cortez, Michael Mina, and Cassandra Munger. Funding for this study came the National Institute of Neurological Disorders and Stroke, National Institutes of Health, NSO 46635, NSO 42194, and NS 103891, the National Multiple Sclerosis Society, pp 191235234, the German Research Foundation, CO 2129/1-1, the National Institutes of Health, DP50. Special promotion. Explore the latest scientific research on sleep and dreams in this free online course from New Scientist. Sign up now. Academy. New Scientist. Com. Courses. Science of Sleep and Dreams. Story source. Materials provided by Harvard Th. Chan School of Public Health. Note: content may be edited for style and length. Chan School of Public Health. Epstein-Barr virus may be leading cause of multiple sclerosis. Science Daily, 13 January 2022. ift.tt/34U-Pi7. Harvard Th. Chan School of Public Health. 2022, January 13. Epstein-Barr virus may be leading cause of multiple sclerosis. Science Daily. Retrieved January 14, 2022 from ift.tt/34U-Pi7. Harvard Th. Chan School of Public Health. Epstein-Barr virus may be leading cause of multiple sclerosis. Science Daily. ift.tt/34U-Pi7. Accessed January 14, 2022. You might not have had that choice if our ancestors had not taken a big gamble with their food. A new study published in Science on December 24 shows that early human foragers and farmers adopted an inefficient high-risk, high-reward strategy to find food. They spent more energy in pursuit of food than their great ape cousins, but brought home much more calorie-rich meals that could be shared with the rest of their group. Hunting and gathering is risky and inefficient, but the rate of return is enormous, said study co-leader, Herman Poncer, an associate professor of evolutionary anthropology at Duke University. We can share our food, and because we got so many calories before noon, we can hang out around each other in this new space, a free time space. Humans spend a lot more energy than great apes. We have big brains that eat up a lot of calories. We live a long time. We can have long pregnancies that produce big babies, and these babies rely on adults for a long time. To find out how humans obtain this extra energy, a group of researchers led by Thomas Kraft, a postdoctoral researcher at the University of California Santa Barbara, and Poncer compared the energy budgets of wild gorillas, chimpanzees and orangutans with that of populations of Tanzanian hunter-gatherer. Humans were thought to maintain their energetically costly lifestyle in one of two ways. They could be super efficient, spending little time and energy finding food. in part due to the use of tools and technological advances, or they could spend a lot of energy to quickly bring home a lot of food. The researchers found that hunter-gatherers and forager horticulturalists are inefficient, high-intensity foragers. Rather than minimizing their costs, they take a risk to maximize their rewards. Chimpanzees, gorillas and orangutans, on the other hand, are like an electric car bringing home a head of lettuce and some apples. What's more, they bring enough to share. Ponser said sharing provides a safety net, enabling some group members to take risks, targeting big game and other high-risk, high-reward foods. If they come home empty-handed, which they often do, they know others will have something to share. The possibility of sharing food also means some group members can even stay at the camp on occasion, enjoying one of our most precious commodities, free time. It allows for experimentation, for learning, for creativity, for play, for culture. Being wired to finding and sharing energy bombs was, and still is, a winning strategy for hunter-gatherers and foragers horticulturalists, Ponser said. But it also can be treacherous for those of us with a pantry full of delicious highly caloric food. We are built to try and get a lot of food, Ponser said. We are hugely ravenous and inefficient, and that's how we've evolved for 2 million years. That doesn't mean we can be careless with our energy today, and it doesn't mean that we have to say, well, there's nothing we can do about it, Ponser said. We have to be aware of ourselves and our evolutionary history. This research was supported by the National Science Foundation, BCS 0422690, BCS 0850815, BCS 1440867, BCS 1062879, BCS 1440841, BCS 1440671, BCS 0242455, NIH R01AG024119, R56AG 024119, the Lembke Foundation, the Max Planck Institute. Make a difference. Sponsored opportunity story source. Materials provided by Duke University. Original written by Marie-Claire Cellini. Note: content may be edited for style and length. The Energetics of Uniquely Human Subsistence Strategies. Science. 2021. 374-6575, doi. 10. 1126, Science. ABF 0130. Cite this page. Duke University. https://ift. tt. 3i8czuy. Access January 14, 2022. Continuing the planet's long-term warming trend, global temperatures in 2021 were 1.5 degrees Fahrenheit, 0.85 degrees Celsius, above the average for NASA's baseline period, according to scientists at NASA's Goddard Institute for Space Studies, GISS, in New York. NASA uses the period from 1951 to 1980 as a baseline to see how global temperature changes over time. Collectively, the past 8 years are the warmest years since modern recordkeeping began in 1880. According to NASA's temperature record, Earth in 2021 was about 1.9 degrees Fahrenheit, or about 1.1 degree Celsius, warmer than the late 19th century average, the start of the Industrial Revolution. Science leaves no room for doubt. Climate change is the existential threat of our time, said NASA Administrator Bill Nelson. 8 of the top 10 warmest years on our planet occurred in the last decade, an indisputable fact that underscores the need for bold action to safeguard the future of our country, and all of humanity. NASA's scientific research about how Earth is changing and getting warmer will guide communities throughout the world, helping humanity confront climate and mitigate its devastating effects. This warming trend around the globe is due to human activities that have increased emissions of carbon dioxide. The planet is already seeing the effects of global warming. Arctic sea ice is declining, sea levels are rising, wildfires are becoming more severe and animal migration patterns are shifting. Understanding how the planet is changing, and how rapidly that change occurs, is crucial for humanity to prepare for and adapt to a warmer world. Weather stations, ships, and ocean buoys around the globe record the temperature at Earth's surface throughout the year. Scientists analyze these measurements using computer algorithms to deal with uncertainties in the data and quality control to calculate the global average surface temperature difference for every year. Many factors affect the average temperature any given year, such as La Niña and El Niño climate patterns in the tropical Pacific. A separate, independent analysis by NOAA also concluded that the global surface temperature for 2021 was the sixth highest since record-keeping began in 1880. NOAA scientists use much of the same raw temperature data in their analysis and have a different baseline period, 1901 to 2000, and methodology. The complexity of the various analyses doesn't matter because the signals are so strong, said Gavin Schmidt, director of GISS, NASA's leading center for climate modeling and climate change research. The trends are all the same because the trends are so large. NASA's full dataset of global surface temperatures for 2021, as well as details of how NASA scientists conducted the analysis, are publicly available from GISS data. GIS. NASA. Governor, GISTEM. The laboratory is affiliated with Columbia University's Earth Institute and School of Engineering and Applied Science in New York. For more information about NASA's Earth science missions, visit www.nasa. Governor, Earth Make a Difference. Sponsored opportunity story source. Materials provided by NASA. Note: content may be edited for style and length. Cite this page. NASA. Past 8 years. Warmest since modern recordkeeping began. 2021 tied for sixth warmest year in continued trend, analysis shows. Science Daily. https://ift. tt. 3 GOI 1 dB. Access January 14, 2022. Past 8 years. Warmest since modern recordkeeping began. New insights into seasons on a planet outside our solar system. Imagine being in a place where the winds are so strong that they move at the speed of sound. That's just one aspect of the atmosphere on XO3b, one of a class of exoplanets, planets outside our solar system, known as hot Jupiters. In a recent paper, a McGill-led research team provides new insight into what seasons looks like on a planet outside our solar system. The researchers also suggest that the oval orbit, extremely high surface temperatures, 2000 degrees Celsius hot enough to vaporize rock, and puffiness of XO3b reveal traces of the planet's history. The findings will potentially advance both the scientific understanding of how exoplanets form and evolve and give some context for planets in our own solar system. Despite being the most studied type of exoplanet, major questions remain about how they form. Could there be subclasses of hot Jupiters with different formation stories? For example, do these planets take shape far from their parent stars, at a distance where it's cold enough for molecules such as water to become solid, or closer? To test those ideas, the authors of a recent McGill-led study used data from NASA's retired Spitzer Space Telescope to look at the atmosphere of exoplanet XO3b. They observed eccentric seasons and measured wind speeds on the planet by obtaining a phase curve of the planet as it completed a full revolution about its host star. Looking at atmospheric dynamics and interior evolution, this planet is an extremely interesting case study for atmospheric dynamics and interior evolution, as it lies in an intermediate regime of planetary mass where processes normally neglected for less massive hot Jupiters may come into play. Saw. This suggests that it recently migrated toward its parent star. If that's the case, it will eventually settle into a more circular orbit. The eccentric orbit of the planet also leads to seasonal variations hundreds of times stronger than what we experience on Earth. They suggest that the possible source of this heating could be due to leftover nuclear fusion. Excess warmth and puffiness due to tidal heating? Observations by Gaia, an ESA, European Space Agency, mission, found that the planet is puffier than expected, which indicate its interior may be particularly energetic. The resulting changes in interior pressure produce heat. For Dang, this unusual hot Jupiter provides an opportunity to test ideas about which formation processes may produce certain characteristics in these exoplanets. Story source: materials provided by McGill University. Note: content may be edited for style and length. Journal reference: Lisa Dang, Taylor J. Bell, Nicholas B. Cowan, Daniel Thorngren, Tiffany Kataria, Heather A. Knutson, Nicole K. Lewis, Kevin G. Stassen, Jonathan J. Fortney, Eric Agel, Gregory P. Laughlin, Adam Burrows, Karen A. Collins, Drake Deming, Diana Jovamir, Jonathan Langton, Sarah Rastegar, Adam P. Showman. New insights into seasons on a planet outside our solar system. Observations of a hot Jupiter may also advance our understanding of planet origins and evolution. Science Daily. New insights into seasons on a planet outside our solar system. Observations of a hot Jupiter may also advance our understanding of planet origins and evolution. Science Daily. New insights into seasons on a planet outside our solar system. Martian meteorites. Organic materials. Origin not biological, formed by geochemical interactions between water and rock. Organic molecules found in a meteorite that hurtled to Earth from Mars were synthesized during interactions between Wa. The meteorite, called Allen Hills, ALH, 84001, was discovered in the Antarctic in 1984 and is considered one of the oldest known projectiles to reach Earth from Mars. Analyzing the origin of the meteorite's minerals can serve as a window to reveal both the geochemical processes occurring early in Earth's history and Mars' potential for habitability, explains Steele, who has done extensive research on organic material in Martian meteorites and is a member of B. Organic molecules contain carbon and hydrogen, and sometimes include oxygen, nitrogen, sulfur, and other elements. Organic compounds are commonly associated with life, although they can be created by non-biological processes as well, which are referred to as abiotic organic chemistry. For years, scientists have debated the origin story for the organic carbon found in the Allen Hills 84001 meteorite, with possibilities including various abiotic process related to volcanic activity, impact events on Mars, or hydrological exposure, as well as potentially the remnants of ancient life. They found evidence of water-rock interactions similar to those that happen on Earth. The samples indicate that the Martian rocks experienced two important geochemical processes. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.